When we shop for a smartphone or a laptop, there's always that one number we just zero in on.
Right, the battery size.
Exactly. We just assume a bigger battery automatically means, more time between charges.
Yeah, I mean, it is a comforting logic. We naturally just equate physical capacity with stamina.
But in the world of electric vehicles, that simple math completely falls apart. So today on our deep dive, we are crossing data from a few really interesting sources.
Yeah, we have a recent real-world highway test from Rome, a 2026 efficiency ranking, and the latest electric charging cost guide.
Right. And our mission today is to figure out why battery size isn't everything. Okay, let's unpack this. Why are buyers still so obsessed with massive batteries when smart aerodynamic design is, well, beating them at their own game?
Well, it comes down to a fundamental misunderstanding of physics, really,
Yeah.
and how vehicles actually use energy.
Which brings us to that Rome test.
Yes, exactly. To understand efficiency, we have to look at real-world data that just shatters that whole bigger is better myth. They took a fleet of EVs out on the GRA, the ring road in Rome.
Right, to test the actual real-world highway range.
Yeah, and the BMW iX3 traveled an impressive 586 kilometers. But to do that, it had to rely on a massive 108.7 kilowatt-hour battery.
Which sounds great, right? Until you look at the Mercedes CLA, it traveled 577 kilometers.
Yeah, so just 9 kilometers less?
Right. Literally just 9 kilometers less than the BMW, but it did it using a much smaller 85 kilowatt-hour battery.
It is wild.
It is like trying to win a marathon by carrying a massive heavy backpack of snacks just to stay fueled up versus just having an incredibly efficient metabolism.
Oh, that is a great analogy. And what's fascinating here is the mechanics behind that efficient metabolism, because aerodynamic drag increases exponentially with speed.
So a car shaped like a teardrop just needs vastly less power.
Exactly, way less power to maintain highway speeds than, say, a vehicle shaped like a brick.
Right.
That is how the CLA managed it. And the Ford Puma Jenny is another great example. It is highly compact, weighs only 1,488 kilograms. So both of them hit this incredibly low energy consumption of just 14 kilowatt hours per 100 kilometers.
But because that efficiency relies so heavily on slicing through the air and, minimizing weight, the moment you change your driving environment, the math changes completely.
Oh, absolutely. It flips traditional car logic on its head.
Right, because, wait, so being stuck in frustrating stop-and-go traffic is actually good for your fuel economy?
Yeah, I know it sounds crazy, but EVs get like 15 to 25% better mileage in the city.
Wow.
Yeah. A really light car, like the Lancia Ypsilon, translates to an amazing 6.3 kilometers per kilowatt hour in urban settings.
But the second you hit 130 kilometers per hour on the highway...
Or if the temperature drops below 5 degrees Celsius.
Right, then your range just plummets.
Yeah, because then it becomes a pure fight against aerodynamic drag and thermal management. But in the city, you have regenerative braking.
Oh, right, turning stopping into charging.
Exactly. In the city, you are constantly recycling your own kinetic energy. You aren't just wasting your forward momentum as heat on the brake pads like a gas car does.
And mastering that regenerative braking leads directly to your wallet.
It really does.
Looking at the Electra data, if you charge at home, you are paying roughly 4 to 6 euros to drive 100 kilometers.
Right, compared to what, 10 or 11 euros for gas?
Exactly. The financial advantage is massive. Yet, if you look at the broader car market, the average EV efficiency has actually been declining since 2018.
It is so frustrating.
It is. So what does this all mean? Are we just defeating the financial and environmental purpose of EVs by demanding these heavy, boxy trucks?
Well, consumers want the stamina, but they refuse the vehicle shape that actually provides it. They want these massive SUVs that literally have to push a wall of air out of their way.
When weight and frontal area are the absolute enemies of energy efficiency.
Exactly. Meanwhile, sleek sedans are completely dominating the efficiency rankings, like the Lucid Air. It gets an astounding 23 kilowatt hours per 100 miles, which is about 14.3 per 100 kilometers.
Rivaling the Mercedes CLA.
Right, simply because it cuts through the air so cleanly.
It just completely reframes the whole range anxiety debate.
It really does.
The ultimate cure isn't a heavier giant battery, it is radical aerodynamic efficiency. As the Mercedes CLA proved, smart design can easily beat a battery 20 kilowatt hours larger.
You don't need the heavy backpack if your running form is perfect.
Exactly. Well, thank you so much for joining us on this deep dive today. We always appreciate you taking the time to explore these concepts with us.
Yeah, thanks for tuning in.
And we want to leave you with a final provocative thought to mull over. If aerodynamics and software are consistently beating pure battery size, Will the next massive leap in driving range come from a wind tunnel rather than a battery lab?